Everyone, in this video we are going to see the single phase fully controlled bridge rectifiers with RL load. Three types of analysis we can done, that is R load, RL load and RLE load. In this video we are going to see about RL load. Fully controlled rectifier. Rectifier means it is converting that AC voltage into a DC voltage. That is, input is AC and output is DC in single phase fully controlled rectifier. Fully controlled rectifier means, that is, name indicates that all four thyristors are controlled. It means all four thyristors are controlled by the gate pulse. If it is half controlled rectifier, only two thyristors were controlled and half of the circuit, and the remaining two diodes were uncontrolled device we will use. In this, four thyristors are connected with the single phase supply and connected with the load R and L. The output, in this diagram, the output indicates that plus minus, that is VDC, that is DC output voltage. Here, when we are giving a supply to the single phase, that is single phase AC supply we are giving to the circuit, it will passes through T1 and T2 through the load to the negative supply, which indicates when we are giving a positive negative. The positive goes to the T1 anode and it is connected to the load resistor, inductor, and it move on to the anode of T2, and the negative supply is connected to the cathode of T2. So the circuit will be closed like this until starts producing the DC output voltage, which is indicated in the waveform. That is, first waveform shows that is first axis shows that single phase AC supply, and the second axis shows that delayed, that is what firing angle we are giving in the gate pulse. It will be delayed by some angle, that is alpha, and it starts conducting from where it shows that T1 and T2. The delayed angle is T3 and T4, that is negative spikes, and it keep on conducting up to pi, and the negative spikes will go on increasing in the negative region, and again the second pulse will start from pi plus alpha. In this pi plus alpha region, the thyristors T3 and T4 will conduct. How? The positive supply will be interchanged, that is, a positive and negative will be interchanged in the single phase input supply, so that anode will be positive will be given to the thyristor T3 and negative supply will given to the cathode of T4. The circuit will closes like this, that is positive from Vs T3 and RL T4 to the negative supply of Vs. In this point where the output will conduct from T3, the output will conduct in the positive region, so that input supply is in negative, we are getting output in positive. So like this, pi plus alpha, it will conduct up to 2 pi. What is this negative spikes? The behavior of the inductor is the charging and discharging. When the thyristors T1 and T2 conducts, it will keep on charging in the positive negative side. Once we are turn offing the T1 and T2, and it will be delayed by some angle, and we are turning on the T3 and T4. There will be some time between pi to pi plus alpha. In this region, the inductor gets discharged. By changing the sign of the inductor, it will get discharged through the negative region up to the next gate pulses will arrive. When the next gate pulse will arrive, that is pi plus alpha, it will start conducting for the next two devices. This is the negative supply. Then the third axis shows that the current, it starts from negative, that is negative spikes region, where it go on conducting up to the peak value of Vm, and it starts conducting like this, positive and negative alternatively. This is single phase fully bridge controlled rectifier with RL load. The second diagram shows that fully controlled rectifier with freewheeling diode FD. What is the purpose of freewheeling diode? When we are comparing these two waveforms, input is same and the output current is same and the output voltage there is no negative spikes. The reason for using the freewheeling diode is to eliminate the negative spikes appearing in the output. So when we are using the freewheeling diode, that conduction time between pi to pi plus alpha, the inductor discharges through the freewheeling diode and it circulates through inductor, freewheeling diode and R. So the inductor charges will get discharges from pi to pi plus alpha. When the next gate pulse arrives, it starts conducting from pi plus alpha. So the purpose of freewheeling diode is to eliminate the negative spikes appear across the RL load. When we are using R load, there will be no negative spikes, because when we are using L load, the spikes will appear. Thank you.